Okay, this is Dr. Bishop. Once again, I'm going to give a lecture on correlational research. To begin this, I should mention and define the concept of variables. Generally, when you do correlational research, you're studying the relationship between two or more variables. So a variable is anything that can have more than one value. Height would be an example, weight, gender, male or female, almost anything. So in correlational research, the two variables that you pick two variables to see if they're related. And then you measure them as they exist in nature, and the variables are not manipulated. So you take and you do a survey of intro psych students, and you check to see their alcohol use and their GPA, but you don't manipulate that. So you just check to see what already exists. And this is the example at the bottom here that I just mentioned. So the question you're asking, if you're using this example, is are alcohol use and GPA related? And more specifically, do people who drink more alcohol also have lower grades? When you take your sample, you give your survey, maybe you have 100 people take this, and for each subject you collect the amount of alcohol used and your GPA. So each subject is measured on both variables. And then through numerical manipulations and formulas, you calculate something called the correlation coefficient. This is represented by the symbol R. The number you actually come out with represents the strength and the direction of relationship. The strength, generally the degree of relationship, is the absolute number that you come out with, and it varies from 0 to 1. The direction of relationship is indicated by the sign minus if it's a negative relationship, or plus if it's a positive relationship. Generally speaking, as one variable gets greater and the second gets greater, like height and weight, in general, if that's the relationship, you have a positive correlation. And if it goes the other way, you have a negative correlation. Some examples of this are, for positive correlation, if you have amount of stress that you're experiencing, and depression. So as the stress level goes up, so does depression. A second example would be your ACT score and your grade point average. It turns out that I've actually measured this and calculated a correlation coefficient, and the correlation coefficient is 0.5, a plus 0.5. Also, educational achievement is positively correlated with income over the lifespan. Negative correlations involve where you have higher scores on one variable and lower scores on a second variable. For example, social support is negatively correlated with depression. So the more social support you get, the lower, say, your depression score would be. Amount of aerobic exercise per week and your body weight. Generally speaking, exercising more is related to lower weight. Marital conflict, amount that you fight, and your total marital satisfaction is negatively correlated. So again, the higher the strength of the relationship is measured by the higher absolute value. So in this case, 0.92 is a higher correlation than 0.65. Likewise, independent of this negative sign, 0.83 is higher than 0.24, even though it's a a negative relationship. The value of 0 means that there is no relationship between the variables. As one varies, the other does not vary systematically with the first. A graphical representation of data collected in correlational studies, you can draw it out, and it's called a scatter plot. The important thing to recognize that each point on the scatter plot represents a subject in the data set. So if you have 100 points in the scatter plot, that means you have 100 subjects, and they've each been measured on each of the two variables, and each point represents the intersection of that one subject on the two variables. So here's an example of that. It's a little hard to see, but the actual calculated correlation coefficient here is 0, positive 0.3, positive 0.8, and positive 1. Now these are theoretical, but you can see by the distribution of dots here that there's no linear relationship. Scoring number of hours studying on an exam is not correlated with high or low scores. Now, in general, I've done studies like this before, and the amount studied does correlate with the score that you get on the test. So depending on how strong the correlation is, you might get something that looks like 0.3, where there's a general trend, more time spent correlates with a higher score. If it's even a higher relationship, you get, like, for example, 0.80. You can see here that it's more obvious that the more time you study, the higher your score will likely be. If it's a perfect correlation, which you don't see often, the total amount of study time correlates perfectly with your score. And so you could predict your score based on total amount of study perfectly. Here's another example where you can read it a little easier. And the thing to notice here is the correlation coefficient is 0. In this case, it's 0.3, and you can begin to see that there's a relationship between how people do on this variable and this variable. It's an even stronger relationship here, and it's a perfect relationship here where the points fall exactly on a straight line. Remember that each point represents a particular individual on both variables. Like this point would be, this person studied maybe 18 hours and achieved a score of 95% or something like that. Here's the opposite, a negative relationship. The number of beers the night before a first exam, heavy drinking on the y-axis, so maybe 20 beers, and the score on the first examination. If you have, again, a no relationship, drinking beer and how you score is not correlated. You could have a lot of beer and still score high. In reality, it probably is a negative correlation, so that the more beer that you drink, say 15, 18, 20, beers, then your score is going to be 50%. You're going to get a D or an F, or you're likely to. And if you haven't drank at all, the correlation, you may be getting better scores. So it looks like maybe the beer drinking might be related. It is related. You don't know if it's causing it, but it may be related. The next chart shows a hypothetical negative 80.8 correlation, and you can see the relationship is even stronger. And a perfect correlation, negative, would look like this. And here again, you can see it more specifically where you have a -1 correlation coefficient, a -0.7, a -0.4. You can tell by the look of the scattergram, the likelihood, you can almost predict the correlation coefficient by looking at the picture of the data set. So here's a review question. Which of the following variables would you expect to be negatively correlated? Cigarettes smoked and alcoholic beverages consumed. But I can tell you that turns out to be a positive correlation. If you'd studied a group of alcoholics, they drink a lot, and the more they drink, the more they smoke in general. Also, if you have salary and job satisfaction, those are positive correlated. And the answer here to this question is number C. You eat a lot of vegetables, you're not going to gain as much weight typically, and you have lower body weight, so that's a negative correlation. Number of unprotected sex encounters and the number of STD infections, positive correlation. Yeah, you're not careful of what you're doing. You have lots of partners, you're going to have higher STD infections. That's positive correlation. The following correlation coefficients, which one represents the strongest relationship? Again, strongest means the absolute number. 0.93 is minus 0.93 is the answer, but it's the 0.93 that actually makes it the strongest relationship. Another question, if you have an insurance company and they want to try to predict your likelihood of having an accident, and they collect data on gender, age, marital status, and a variety of other things, they're trying to predict the likelihood of accidents by your predictor variables, age, sex, and so forth. Which correlation coefficient between your your predictor variables, gender, age, or marital status, and likelihood of an accident would you be most interested in? And it turns out, again, the one that would be the most predictive, have the strongest relationship would be 0.73, even though it's a negative 0.73. So one of the big problems with correlational research is you get confounding of variables and you can't ever tell exactly how to interpret the results because these variables are confounded or intermixed one with the other. So again, if you had the alcohol use and GPA example, it might show a negative correlation. Students who consume greater number of alcoholic beverages per week have lower GPAs. And does that mean that drinking greater amounts of alcohol causes students to get lower grades? Turns out you can't draw that conclusion. So here are some possible interpretations given that correlation. It could be that actually that's true, that heavy drinking causes lower grades. And kind of intuitively you would think that might be the association and interpretation. But if you think about it, if you're just doing poorly in school, and then you might start drinking more because you're distressed, or just maybe you get less interested in your schooling and start partying. So it might be a relationship of lower GPA precedes and causes heavy drinking. Or it could be that there's some, third variable. Maybe your life isn't going well and you have higher stress, and that's causing you not to study as much. Your GPA goes down. Also, you're not happy, and you make yourself feel better. You drink a lot of alcohol. So it could be that stress is causing both of these things, and actually there's no relationship at all between, in terms of causation, between the alcohol use and the GPA. Also in correlational research, you have what they call, what I just indicated is the directionality problem and third variable problem. But the directionality problem is where you don't know which direction the relationship is going. Is it drinking leading to poor grades, or poor grades leading to drinking? That's you get a correlation, you don't know which way it's going here. Now, sometimes you can untangle this by doing longitudinal research. So if you study the sequence of the way these things are happening, you might find out that you're starting your heavy drinking follows your lower GPA, or your poor your poor student performance. So that would give you a clue that the poor student performance is actually maybe contributing to the drinking. Again, the third variable problem is when you have some other variable that's related to both. And so you never know what other variables are operating when you have a relationship. And then in the example I just gave, stress from some other factors may be correlated to both drinking and grades. There's actually, when you have multiple variables, there are statistical techniques to untangle the direction of the correlation, but I'm not going to get into that in this lecture. It's beyond where I want to go. So here's another question. You have a talk radio show, and research suggests a positive correlation between age at first sex for teens and self-esteem. What does this mean? Does it mean that waiting until one is older to have sex causes higher self-esteem? It turns out that you can't draw that conclusion. So the answer to this question would be no, that interpretation is not warranted. Some other possible interpretations would be if you're waiting until one is older to have, well, here are all the possible interpretations. It could be that actually waiting does cause higher self-esteem. That's the first one here. It could be that having higher self-esteem precedes having sex and causes teens to wait to have sex. Or it could be that there's some third variable, for example, really conservative parents, and they cause the kids to have higher self-esteem and to wait to have sex. And so it's just really impossible to disentangle them for sure. If, again, you wanted to try to see which factor maybe was more responsible or the direction of the correlation, you could kind of measure to see which variable, self-esteem or having sex, comes first, and if it then results in the other one being affected. How could you know for sure whether having sex causes low self-esteem? Without conducting a full-blown experiment, you couldn't know. So if you could actually do this experiment, which you can't, and you'll understand in a moment why not, but you'd have to do a true experiment. Well, to do that, you'd have to get a group of subjects, maybe a group of 12-year-olds, and you'd have to randomly assign them to two groups, and the experimental group would be the subjects, the kids who maybe are going to have early sex, and you'd tell everybody in that group, have sex when you're 14, and the other group you would tell, don't have sex until 18, and then you'd check to see if there was higher self-esteem in one group versus the other. Obviously, you can't do that. You can't control that. And here's the point. It's not possible in many cases to conduct a true experiment, and particularly in abnormal psychology. You cannot manipulate, for example, the amount of trauma that a person is exposed to in childhood, and then see. You can correlate it, but you can't cause it. You can't take a group of people and say, have your parents beat you up when you're 3, and then check to see if you get multiple personality disorder. What you can do is correlational research to see if people who have a diagnosis of multiple personality disorder actually have had a history of childhood abuse. And it turns out in that case that there is a correlation, positive correlation. Correlational research is often used in epidemiological research, and you study the incidence, prevalence, and risk factors. An example I previously gave was people who developed AIDS, and when this first started, no one knew exactly what was going on. They just knew certain people were getting sick and dying. And this was in the early 1980s. And so they started doing epidemiological research. In other words, they started to check to see if people who were having this disorder, what that was correlated with. And what they did find was it was correlated with being male, being gay, having sex with multiple partners, having certain specific kinds of sex, like anal sex. And so those correlates of the condition were then defined as risk factors. And negative correlates were defined as protective factors, having fewer partners, being heterosexual, and so forth. Correlational research is also conducted in behavior genetics research, where you take people who vary in a number of shared genes. Say, for example, parents and children share 50% genes, identical twins 100%. So you take, and see if a number of shared genes correlates with the likelihood of having a disorder. It turns out for some of the major mental disorders, there is a correlation. For schizophrenia, the correlation is about 0.5. So that, for example, if you're identical twins, you have the concordance rate. If one has the schizophrenia and the other identical twin is about 50% likely to also have the disorder or to develop it. Whereas if you just share 50% of genes, like just siblings, or then the rate of concordance, or where one has it and the other is about 20% likely to have it. So the number of shared genes, the correlation between shared genes and having the disorder, suggests that hereditary factors are involved. Okay, we're going to stop here.